Hey guys, welcome back to another video. So in this video we are talking about new James Webb Space Telescope images. I know that's been a bit late since I've done some James Webb images, but the Tarantula Nebula is a large H2 region, or is in the large H2 region in the Large Magellanic Cloud, which the Milky Way is within. The apparent magnitude is 8. This nebula, Tarantula Nebula, was discovered by Nicolas Louis de la Caille between 1751 and 1753 on a trip down to South Africa. This nebula is a larger nebula. It is 931 light years across. The Tarantula Nebula is 160,000 light years from Earth. The Tarantula Nebula has multiple nebulae inside of it, which include NGC 2070 and Hodge 301, which has had a supernova. VFTS 243 is its black hole. It has at least 9 solar masses. Not a strong black hole, nor is our black hole Sagittarius A star. SN 1987A is the only known supernova in the Tarantula Nebula. SN 1987A was a Type 2 supernova in the Large Magellanic Cloud. It was roughly 51,000 parsecs, or 168,000 light years from Earth. It peaked in May of 1987 at a magnitude of about 3. SN 1987A was due to the B3 supergiant Sanduleak 69202 when it exploded. So here you have VV191. It's a galactic cluster with 2 galaxies. I could not really find that much information about VV191, but they're not interacting. This is just because the way that we see them, it looks like they are interacting. Here is IC5332. Also known as PGC 71775, which is just a more boring name. IC5332 is an intermediate spiral galaxy, which is 28.8 million light years away. This galaxy is in the constellation Sculptor, and the galaxy magnitude is 10.72. So here is Orion 294-606. Which is a silhouette circumstellar disk. It is roughly 300 astronomical units across, which is 10 times the distance from the Sun to Neptune. What you're seeing here is a silhouette circumstellar disk, which in layman terms is just a nebula type object, but for the solar system. So we can study Orion 294-606 for the next very long time and see how our solar system formed. I could not find a lot of information about Orion 294-606, except for this link that will be in the description if you want to go more in depth, see this image, and just a lot of space dilly-da-do data. So, here's 2 galaxies. The cluster is called IC1623. IC1623 is an entwined pair of interacting galaxies, which lies around 270 million light years away. This is an interesting image because it could show what the Milky Way and the Andromeda Galaxy will look from a far vantage point, due to that the Milky Way and Andromeda Galaxy will be merging sometime within the next billion years. Within the next few billion years. IC1623 is in the constellation Cetus. So this is the famous updated Pillars of Creation, or just Messier 16. NGC 6611 is a emission nebulae. Sharpless 49 is in the H2 region. RCW165 is in the constellation Serpens. CR375 is 6,500 light years away. GUM 83 has an apparent magnitude of 6.4. The brightest star in the Star Queen Nebula is HD 168076, which has an apparent magnitude of 8.7. HD 168076 is a binary star system. The Messier 16 has had no supernovae but there are signs that one have occurred from data from the Spitzer telescope, but has not been fully confirmed yet. So, here is a quasar. It has the extremely long name of SDSS J165202.64 plus 172852.852.3, or a shorter name is SDSS J1652. So SDSS J1652 is a quasar, which is a extremely hot galactic and luminous galactic nucleus. It also has a giant supermassive black hole. The quasar is showing the start of a cosmological galaxy, you could say. This quasar is extremely far, at 11.5 billion light years away. The nearest quasar to Earth is 600 billion light years away. That is a significant distance. The main image that you see on the left is a Hubble image. The image from Webb you can see on the right, and then you can see the speeds of emissions from doubly ionized oxygen. The warmer the color, red and orange, means that those molecules are moving away from Earth. The cooler colors, light blue and dark blue, will mean that it is moving closer to Earth. This is not a significant distance, but a difference that the amazing Webb telescope can find. So here we have Hubble and Webb's views at the same time after the impact of the DART mission on Dimorphos. If you want some more information, there is a video in the top right hand corner.
Wow. Yeah. Oh my goodness. 8,
Yeah.
7,
Oh,
6,
wow.
5, 4, 3, 2, 1.
Oh my gosh. Oh wow. Awaiting visual confirmation. All right. Let's see. We got it? Waiting. And we have impact.
So here we have the planet side of things. So here we have Neptune, is the 8th planet from the Sun. Here you have Neptune and Infrared. You have all of Neptune's rings, and some of Neptune's moons. These moons include Hippocamp, Despina, Larissa, Thalassa, Naiad, and Galatea. In the wide shot of this image, you can see Neptune's largest moon, Triton, which reflects 94% of all the light that JWST is looking at. These rings include the Galilei rings, Leverrier rings, Lassell rings, and Adams rings. Neptune's magnitude is 7.67, and Neptune is 29 astronomical units away from Earth. This is a pretty neat image of Neptune. So here we have Mars. We can see into Mars's thin atmosphere. This is the first James Webb Martian atmosphere composition, which implies that the Webb team will go back to Mars sometime in the future. We can see that there is a lot of carbon dioxide, some water, and some carbon monoxide in the atmosphere. So here we have Mars again. We have the James Webb telescope in NIRCam imagery. Webb's first images of a Mars captured by the near-infrared camera, or NIRCam, shows a region of the planet's eastern hemisphere at 2 different wavelengths, or colors of infrared light. The NIRCam shorter wavelength, 2.1 microns, is dominated by reflected sunlight and thus reveals surface details similar to those apparent in the visible light images. The rings of the Huygens crater and the dark volcanic rock of Syrtis Major and brightening in the Hellas Basin are all apparent in this image. The NIRCam, longer wavelength, 4.3 microns, shows thermal emission, light given off as the planet as it loses heat. The brightness of the 4.3 micron light is related to the temperature of the surface and the atmosphere. The brightest region on the planet is where the sun is nearly overhead, because it's generally the warmest. So, another planet, Jupiter. Here we have Jupiter with its northern and southern auroras with their diffraction spikes. You can see the southern aurora diffraction spikes a lot better than the northern one, but if JWST just panned a bit upward, it would probably be the exact same thing. We see the rings of Jupiter, and then we also see two moons, Amalthea and Adjustia, and even the diffraction spike from one of Jupiter's largest moon, Io. We can see Io's footprint in the southern aurora region. So here we have Wolf-Rayet 140, is a interesting image from James Webb. There are at least 17 cosmic rings, most likely even more. SBC 91232 is 5,000 light years away from Earth. V1687 Cygni is within the Cygnus constellation. BD plus 43 degree sign 3571 is a visually moderate binary star at 6.85 magnitude. The weird rings of the binary star HD 193793 is because these stars orbit each other. These rings are kind of like tree rings. HIP 100287 orbits each other every 8 years, which means that we are seeing these rings starting all the way back to 3114 BC. The TYC 3164-1678-1 binary star group started doing this 5,178 years ago, but we've only seen 178 years of them orbiting each other and sending off all this debris. The rings of WDSJ 20205 plus 4531 is due to the orbit of these stars. They fling their dust and stellar winds whenever they orbit each other, and then these stellar winds compact, they compress, and just willow out and becomes this amazing truncated feature that we see from 2 mass J20202 798 plus 4351164. So here we have Max 0647-JD1. Max 0647JD is the furthest known galaxy from Earth. This galaxy has tripled from Earth's view. This was only 400 million years after the Big Bang occurred. CZC 2013 Max 06947-JD1 is a galaxy with a redshift of about 11, which is equivalent to 13.26 billion light years away. It is less than 600 light years in diameter and has over 1 billion stars. It is in the constellation Camellia Portalis. So, James Webb, we soon will see an image of Pluto, and then we will also see a very long image, 17 hours, high redshift galaxies, alignment alpha galaxies, alignment rate galaxies, and starburst galaxies, with an image composition time, you could say, for 17 hours and 6 minutes. So, I hope that you enjoyed this video. If you did, make sure to leave a like and subscribe. Also hit that notification bell so you get notified whenever I create another video. Alright, bye bye, and stay safe.